orbits. So to begin, this lab is primarily concerned with gravity and the motion of celestial objects. All experimentation was performed digitally using VPython closed code programming, so no actual real-world data collection occurred. Part one is the black hole and star system. We're going to be determining the mass of a black hole using the star's motion in orbit around it. And part two is a moon and ship orbiting a planet. We're going to be looking at how the ship's motion is altered by both the gravitational force of the planet on it and the gravitational force of the orbiting moon on it. So for part one, on the left, we have our code that is in the while loop. We're mainly concerned with the momentum of the star and the force of the black hole on the star. So the change in momentum, or the rate of change of momentum, is going to be more associated with the rotation or the swinging of the object as it is orbiting in this elliptical path around the black hole. And the net force is more so going to be concerned with how that momentum is changing, like it is going to be the cause of that change. The force is going to be the black hole pulling its components perpendicular and parallel. Parallel is going to be increasing or decreasing the magnitude of momentum by increasing or decreasing the velocity of orbit, and the uh, parallel or the perpendicular is going to be changing the direction, also affecting the momentum. So at the bottom, you can see we find the mass of the black hole using the values determined in the star's movement and then print it out for us to have in our data. At the top right, you can see the seed is my school email that is determining the initial conditions. And on the right, you can see the how are we determining the arrows for the visual output. But as you can see in the visual output, the arrows aren't even visible. The arrow scale needed to be turned up, and that's something I'm noticing after the fact, but still an error nonetheless. On the left, we have our data coming from the program. It extends far beyond the screenshot, but we are looking primarily at the mean of this entire data set, which comes out to show that the best estimate for the mass of the black hole should be around 1.57 times 10 to the 44th power. So for part two, we have the system with the planet having a moon and a ship orbiting around it. On the left, we have the while loop calculations, which is concerned with the using the force of the planet on both objects and the force of the moon on the ship to display how this is affecting the motion in orbit in our visual output. And in the top right, we have our initial conditions, which is negative 150 for the x component of velocity of the ship initially. And then in the visual output, you can see the ship initially is pulled towards the moon orbiting the planet and kind of goes more in the moon's path of orbit, kind of going outside of it, honestly, and then crosses back over as it is being pulled and worked on by or not worked on, but the force of the planet is changing its path of orbit, and then it comes in closer, crosses back over the moon's path of orbit, and actually is coming closer towards the planet in this kind of like elliptical orbit as well. Then for our source of error, the only source of error, since this was all digital, would be with the computation. So our calculations could be off that we are using in the programming, or just anything else in our programming that could be resulting in any kind of output dysfunctionality. So for discussion, this top one we already discussed, talking about the black hole and how the net force components are different from how the rate of change of momentum is kind of the actual observation in the motion of how it is changing as it is orbiting in that elliptical pattern. And for the second one, let's imagine for our kind of like our second problem where we had multiple bodies, let's imagine a black hole with a star orbiting it, with a planet orbiting the star and a moon orbiting the planet. The most dominant interaction would be the black hole on all of these other bodies since it will be the most massive. These are kind of, going downward in mass. We have black hole, then star, then planet, then moon. And then for our computational model, we would be needing to model the motion using the black hole's force of gravity on everything else in the problem, the star's force of gravity on the planet and the moon, and the planet's force of gravity on the